welcome to the video for C3.2.1 where we're going to look at exothermic and endothermic reactions. So just pause the video and see if you can answer these 3 questions to start with. Okay, so hopefully you know that temperature is measured in degrees Celsius, although you might have answered Kelvin, which is also a valid answer. The word beginning with C that describes the hazard associated with acids and alkali is corrosive, and the safety precautions when we're using acids and alkali is that because they're corrosive, we don't want to get them onto our eyes, so we wear goggles. If you want to, you can pause the video and read the learning objectives. Okay, so we're going to meet 2 words today, so exothermic and endothermic. So sometimes it helps to look at the word stems of these in order to help us remember. So exo means external or outside. Endo means within, inner, absorbing or containing, and therm means heat. So pause the video and think of any words that you know of that contain these terms. So for exo, you might have come up with exoskeleton, which means an animal has got an external skeleton, so the skeleton's on the outside of their body. You might have, it's not quite exo, but exit, so is a door by which we leave and go into the outside. Endo, again, you might have had endoskeleton, because so that's creatures like us that have got our skeleton within the body. Thermal, so you might have come up with thermal clothing, so we have thermal clothing which keeps us in. You might have come up with thermos flasks which keep our heat within our drink so that we can keep them hot, or we could even have a cold drink and keep it cold. So new information from today. So chemical reactions involve a change in energy, and some reactions give out energy, and if they give out energy then we call them exothermic reactions. If they take in energy then they're called endothermic reactions, and that energy is normally in the form of heat or light. So the therm bit means we're normally talking about heat energy, but it can be light energy. So if you think about various chemical reactions you might have seen, so magnesium burning in air, reacting with the oxygen, you get this bright white light, so that's energy being given out as light energy. You might have also had it as sound, so if you've had a hydrogen balloon exploded, you get that big bang, so you get some sound energy being given out. So here's a diagram that represents endothermic and exothermic. So if it's endothermic, it takes in heat. So quite often people get confused and think because it's taking in heat, the temperature is going to go up. But it's what it does with that heat. So it takes that heat from the surroundings and it turns it into chemical energy. So the amount of heat energy is going down and the surroundings are going to get cooler because they are losing heat energy. If it's exothermic, it's giving out heat. So sometimes people think that means it's going to get cooler because it's losing heat. But it's turning chemical energy into heat energy. And that heat energy is given out to the surroundings. And then therefore the surroundings get warmer. And that delta sign just means change, and H we use as enthalpy. So enthalpy or energy, for an endothermic reaction, is going to be greater than 0, so it's going to be positive. And for an exothermic, it's going to be less than 0, so it's going to be negative energy. So key points that we need to copy down. So bond breaking requires energy. So any bond breaking process is endothermic. And bond forming is the opposite. It releases energy. So it's exothermic. So I think it's quite difficult to visualize why bond forming releases energy, but hopefully it's quite easy to get the idea that if you're breaking a bond, you're overcoming a force of attraction between 2 things. And if you want to break that force of attraction between 2 things, you're going to have to put some energy in. So hopefully that makes sense. And then exothermic is the opposite process. So if bond breaking requires energy, bond forming, which is the opposite process, has to release it. So an endothermic reaction doesn't mean that there's just bond breaking happening. So in most reactions, you've got some bond breaking and some bond forming. But it's the balance of these 2 in terms of the strength of the bonds that determines whether the overall reaction is endothermic or exothermic. So if it's endothermic, we're taking in more energy than is released. So the bonds broken are stronger than those made. And if it's exothermic, then that's giving out more energy than is taken in. So the bonds made, because that process gives out energy, are stronger than the ones that are broken, which requires energy. So keywords that we need to learn: endothermic, reaction which takes in energy, and exothermic, reaction that gives out energy. So pause the video here and try and work out which of these are exothermic and endothermic. So hopefully we've got the methane burning in air. So the methane is the gas taps that we have in our classroom. So when we burn those, we give out heat, so it's exothermic. If you put sherbet in your mouth, you actually get a chemical reaction. Your temperature should go down slightly, that's endothermic. A reaction that takes in heat is going to be endothermic. So a reaction giving out heat is going to be exothermic. Heat's transferred to the surroundings, that's going to be exo. It's bond forming, that's going to be exo. Heat is taken from the surroundings, it's going to be endo. Bond breaking, it's going to be endothermic. A reaction in which more energy is released from the bond forming than is needed for bond breaking is going to be exothermic. And water evaporating, if you think about that, it's a physical process, not a chemical process. But in order to make water evaporate, it's gonna take energy from its surroundings, so it's going to be endo. Right, in the next few slides, there's some exam questions. So pause each one, and then unpause, check your answer against the mark scheme, which will be on the next slide. Okay, so pause this and read it, and then the questions on the next slide. Okay, so this wants to calculate the temperature change for each fuel. The first one's been done for you. So the temperature change is just the temperature after minus the initial temperature. So for the first, for A, it's 45 minus 22, which is 23. So pause the video and do the rest. And then once you've done that, it wants you to decide which fuel releases the most heat energy. So pause the video until you've done that and then unpause. Okay, so hopefully we've got 26, 27 and 40, and it's asking you for the fuel that gives out the most heat energy. So we want the one with the biggest temperature change, which is D. Okay, so pause the video and answer this one. Okay, pause the video and answer this question. Okay, pause the video and answer this question. Okay, last question. Pause this one. Okay. That's the end of the video. Thank you for listening. See you next time.